Have you ever pondered about where the Pacific Ocean ends and the Atlantic Ocean begins? This question might seem simple on the surface, but it's a curious conundrum that has piqued the interest of many explorers, sailors, and scientists throughout history. We're talking about two of the largest bodies of water on our planet: the Pacific, the world's largest ocean, and the Atlantic, the second largest. They span thousands of miles, covering more than a third of the Earth's surface. But where do they meet? How do we determine the boundary between these two massive bodies of water? And more intriguingly, how can they be distinctly separate? These questions are not as straightforward as they may seem. There's a blend of geography, science, and history involved in answering them. In this video, we'll explore this fascinating question and discover what geography, science, and history have to say. To begin, let's understand the geographical boundaries of the Pacific and Atlantic Oceans. These two massive bodies of water are not just geographical features, they are vital parts of our planet's life support system, influencing weather patterns, regulating temperature, and supporting an abundance of life. The Pacific Ocean, the largest and deepest ocean on Earth, stretches from the Arctic in the north to the Southern Ocean in the south. It borders a multitude of countries across Asia, Oceania, and the Americas. This vast expanse of water, more extensive than all of Earth's land area combined, is a world of its own, teeming with diverse marine life and mysterious undersea landscapes. On the other side, we have the Atlantic Ocean, the second largest ocean. It extends from the Arctic Ocean in the north to the Antarctic in the south, separating the old world from the new. The Atlantic Ocean borders the Americas to the west and Europe and Africa to the east. It is known for its S-shaped flow of water, the Atlantic meridional overturning circulation, which plays a crucial role in Earth's climate system. While the Pacific Ocean might be the biggest, the Atlantic Ocean is no less significant. It has been a vital route for exploration, commerce, and cultural exchange between the continents it separates. Its warm waters are home to a rich diversity of marine life and have supported human civilizations for hundreds of years. To put it in perspective, imagine standing on a beach in California, gazing out at the vast Pacific, knowing that on the other side of that immense expanse of water lies Asia. Now picture yourself on a sandy shore in Portugal, looking out at the Atlantic, with the American continent somewhere beyond the horizon. So, we see that these two massive bodies of water cover different parts of our world, but where do they meet? This question takes us to the fascinating meeting point of these colossal bodies of water, a spectacle that's as intriguing as the oceans themselves. The meeting point of the Pacific and Atlantic Oceans is a subject of much debate and fascination. The world's largest bodies of water, these two oceans have been the subject of many stories, myths, and even scientific studies. The question is, where do they meet? For many, the answer lies at the southernmost tip of South America, a place known as Cape Horn. It's a dramatic location where the winds whip and the waters churn. It's easy to imagine the two great oceans colliding and swirling together here, meeting and then parting ways. Some even say you can see a line in the water, marking the spot where the Atlantic's warmer waters meet the colder currents of the Pacific. Yet others argue that this isn't the true meeting point at all. Instead, they point to the far north, in the Arctic region. Here, the Pacific and Atlantic Oceans flow into one another through the Bering Strait. It's a less dramatic location, perhaps, but one that carries the weight of scientific evidence. The waters here mix, influenced by tides, temperatures, and the rotation of the Earth, creating a seamless blend of the two oceans. But even as we consider these geographical points, it's important to remember that the separation of these two oceans isn't as simple as drawing a line on a map. The boundaries aren't fixed, but are constantly shifting and changing, influenced by a multitude of factors. In reality, the meeting point of the Pacific and Atlantic Oceans isn't a single spot, but a complex, dynamic system. It's a place where water, wind, and the Earth itself come together in a dance that's been going on for millions of years. While these geographical locations give us a rough idea, the actual separation of the oceans is more complex and involves science. science provides a more nuanced explanation for the separation of the Pacific and Atlantic Oceans. It's not just about physical boundaries or lines on a map. No, it's a fascinating blend of temperature, salinity, and density that create a natural invisible boundary between these two vast bodies of water. Let's first dive into temperature. The Pacific Ocean, especially near its equator, is generally warmer than the Atlantic. This difference in temperature results in varying water densities, with colder water being denser than warmer water. Now, these differences might seem minor, but on a planetary scale, they're significant enough to prevent the free mixing of water from these two oceans. Next up, we have salinity, or the salt content in the water. The Atlantic Ocean is saltier than the Pacific. This is due to a combination of factors like the rate of evaporation, fresh water input from rivers, and even the amount of sea ice near the poles. Higher salinity means denser water, and this denser water doesn't easily mix with the less salty and thus less dense water of the Pacific. Now, let's talk about density. As you might have guessed, the differences in temperature and salinity lead to differences in water density. Denser water tends to sink beneath less dense water, creating a stratified layered effect in the ocean. This stratification acts as a kind of barrier, preventing the two oceans from just blending into one. These factors also influence the types of marine life and ocean currents in the Pacific and Atlantic. Each ocean has its own unique ecosystem, with species adapted to the particular conditions of their home waters, and the currents, driven by temperature and density differences, follow distinct patterns in each ocean. So it's not just geography, but also the unique characteristics of each ocean that create a boundary. It's a captivating dance of science and nature, playing out on a grand scale beneath the surface of our planet's waters. History also sheds light on the distinction between the Pacific and Atlantic Oceans. The story of how we came to understand the boundaries of these vast bodies of water is as vast and intriguing as the oceans themselves. It's a tale that takes us back to the age of discovery, a time when brave explorers set sail into the unknown, driven by a thirst for knowledge and the promise of new lands. Their voyages not only expanded the known world, but also our understanding of the oceans. Consider Christopher Columbus, the Genoese explorer whose name is synonymous with discovery. In 1492, he set sail westwards from Spain, hoping to reach Asia. Instead, he stumbled upon the Americas, effectively opening up the Atlantic Ocean's vast expanse for further exploration. But the Atlantic is only half the story. The Pacific Ocean, the world's largest and deepest ocean, was a mystery to Europeans until the early 16th century. That's when Portuguese explorer Ferdinand Magellan embarked on an expedition to find a westward route to the Spice Islands of Indonesia. His voyage led him through the strait that now bears his name, the Strait of Magellan, and out into the open Pacific. Magellan's journey revealed the Pacific's vastness and its separation from the Atlantic. His voyage, along with those of other explorers, helped to shape our understanding of the world's oceans, their boundaries, and how they interact. Yet, it wasn't just the explorers who contributed to our knowledge. Cartographers, the mapmakers of the time, played a crucial role too. They took the explorers' findings and used them to create increasingly accurate maps, helping to define the oceans as we know them today. It's fascinating to think that our understanding of the world's oceans, their boundaries, and their interactions has been shaped by the curiosity, bravery, and ingenuity of those who lived centuries ago. Thus, history too has played a role in shaping our perception of where one ocean ends and the other begins. To conclude, the question of where the Pacific Ocean ends and the Atlantic Ocean begins is more complex than it seems. Our journey has taken us through the geographical boundaries, where we've learned that these two colossal bodies of water meet at the southernmost point of South America, where the Cape Horn marks their convergence. We've also delved into the science behind the natural separation of these oceans, understanding that factors such as temperature, salinity, and density of water play critical roles in maintaining their distinct identities. From a historical perspective, We've explored how the notion of separate oceans has shaped maritime voyages and global exploration. In essence, the separation of the Pacific and Atlantic Oceans is not just a geographical fact, but a fascinating interplay of science, history, and nature's own boundaries. So next time you gaze out at the vast expanse of the ocean, remember that there's more than meets the eye. Thanks for joining us on this oceanic exploration.